Hi, geometry students. Here we're in section 4-5, and we're going to be proving triangles congruent using ASA, which is angle side angle, or angle angle side, which is AAS. So, new vocabulary in this section is included side, and so we have the first postulate here is called the angle side angle. So we have an included side, which would be the side that's in between two angles. So let's look here. Let me find my cursor. Lost it. There it is. So we have angle B, we have angle A, and then we have the side which is in between, and that's the included side. So that's the new terminology. Okay, and we have angle B congruent to angle E. Tell about the single arc. And we have the double arc showing that A and D are congruent. Okay. And then we have the included side with the tick mark. So if you have angle side angle, we can conclude that triangles are congruent. We're going to use ASA to prove the triangles are congruent, and we're going to write a two-column proof. Okay, so let's think about what we have here before we make the two-column proof. It tells us that L is the midpoint of WE. So that kind of tells us, right, that this side length is congruent to this side length. We also know that WR, right, is parallel to ED. Okay, and that's going to tell us some information, okay, about angles and other angles other than these two right here, right? These two angles are congruent because they're vertical. So if we can get angle E, right? If we can get angle E to be congruent to angle W here, then we can use the angle side angle. Let's see what happens in our two-column proof. Okay, so we have L is the midpoint of WE, and that's given. And therefore WL is congruent to the LE, and that's what we said. We also have that the two sides are parallel. That's given. And therefore angle W and angle E are the alternate interior angles. So that's the one thing we said, W and E. Those are going to be alternate interior, right, of our, and our transversal is line segment RD. Okay, going back, so we have that. And we also have the vertical angles theorem helps us find the two angles are vertical from each other are congruent. And therefore the triangles are going to be congruent by ASA, just like we thought. Alright, check your progress. Okay, fill in the blank excuse me, in the following paragraph proof. Okay, let me pull this down a little bit. Maybe you can see this is something. Let's do this. There we go. We have angle ABD is congruent to CBD because alternate interior angles are congruent. So ABD, so this angle here, right, is congruent to the CDB. So those are alternate interior when the lines are parallel. We also have angle ADB and angle CBD because they're alternate interior angles. Okay, so we have some common things made up. ADB, so this angle here, right, and the angle CBD, which is up here. Okay, and then we also have that BD. Looks like this side is going to be congruent to itself by the reflexive property. So think about which postulate, right? Which is it, side, side, side? Okay, go ahead and pause your video to make your choice. Right, it's going to be angle, side, angle. Angle, the included side, and then the next angle. Therefore, ASA. Okay, we have also the angle, angle side. So this is different because we don't have the included side. Right, we have one of the other sides. So we have the two angles. Okay, and then a side that's not included. So if we have angle, angle side, we can also prove congruence. Okay, and here's then the proof of the angle, angle side theorem. Okay, so let's see what we can do with this. So angle, angle side. All right, so we're given that NKL. So angle NKL. So this angle up here, right, is congruent to the angle NJM. So let's put a little line like that, right? So the one single line showing congruent angles. Wish that was a different color, but we'll make it thicker so you can see it. Okay. We also are given that KL and JM are congruent segments. So I'm going to put a tick mark here and a tick mark here, and that represents the whole side length. Okay. Now it looks like that this angle here is going to be congruent to itself because of reflexive. Therefore, we have two angles and a non-included side. Therefore, the two triangles are congruent. Let's write a paragraph proof. Okay. So we have NKL congruent to NJM, and that's given, obviously. KL congruent to MN, and angle N is congruent to angle N by the reflexive property. Therefore, the triangles are congruent. Okay, by the AAS. And then by the, remember, see what we're trying to prove, look back at the statement was, whoops, we're trying to prove, not just the triangles are congruent, we're trying to prove that the line segments LN are congruent to MN. So we're trying to prove that the LN segment, you can see here, right, is congruent to this one. Okay, and remember, those are, if you look at it, that's actually a side of the triangle, isn't it? The triangle NJM, and the LN side length is the side of the triangle NLK. Okay, once we get two triangles being congruent, then we could say by any other part of the triangle is going to be congruent corresponding, right? Therefore, by corresponding parts, right, of congruent triangles are congruent. That's how we can show that LN is congruent to MN. Complete the flow proof. Okay. So basically, we're looking for what is given, right? So pause your video to decide on which choice here is the reason why we can say that the two triangles are congruent. Pause your video and make your choice. Okay, we have angle, angle, side. Okay, and what we can see here, right, it's pretty easy to see that this is an angle relationship being congruent, and so is here. So we have to have something that has two angles in it. So it can't be SSS and it can't be SAS. Okay, it's got to be either ASA or AAS, and our side is not included. The EC and the DB congruency, right? Those sides are not in between the two angles. Alright, here's a real-world example. Barbara designs a paper template for a certain envelope. She decides the top and bottom flaps to be isosceles triangles, okay, that have congruent bases. So that's how they're marked down there. Okay, and we have the two angles being E and V being the same. It says if EV equals 8 and the height of the isosceles triangle is 3, we're going to find PO. Okay, so we want to find that length right there. Okay, let's see what happens. in order to determine the length of PO, we must first prove the two triangles are congruent by ASA. Okay? By definition of isosceles triangles, NV is going to be congruent to EN. NV, right, is going to be congruent to EN. Since they total isosceles, right, we have two sides being the same, at least two sides. So we have, right, that this is congruent to this. Okay, we have the EN and the NV. So we have the EN and the NV being congruent, and we have then EN being congruent to PO by CP/CTC. And NV is going to be congruent to PO by the transitive property. This is what we have, right? We have NV congruent to EN, and we have EN being congruent to PO. Therefore, the NV is going to be congruent to PO. It's called the transitive property. And since the height is 3 centimeters, we can use the Pythagorean theorem to calculate PO. The altitude of the triangle connects to the midpoint of the base, so each half is 4. Therefore, the measure of PO is 5. We have a 3, 4, 5 right triangle. Go back and look at the picture to verify those measurements. Okay, so which method would you use to prove triangle ABE is congruent to CBD? So you can see the triangles right up here in the curtain here, right? And then the second triangle being over here. Okay? So we know the curtain decorating the window forms two triangles at the top, and B is the midpoint, right, of AC. That tells me that this side length here is congruent to this side length here, isn't it? Okay. It also tells us AE is equal to 13 inches, but so is CD. Well, equal measures means congruence, so we have congruence here. Okay. It also says BE and BD each use the same amount of material, 17 inches. So it looks like we might have these being the same as well. And you are right, it is side, side, side. Okay, proving triangles congruent. We have the 4 different methods. You need to know these 4 methods for your test and be able to verify them. You're also going to have to make sure you can do a 2-column proof, okay, and probably a paragraph proof. I probably won't make you do a flow proof.